We're going to be doing 9-2 today, and this is the one thing that's a bit tricky in this whole chapter. It's really the only thing that we're going to learn in the whole chapter, and it's that you must reverse the inequality, the alligator, when you multiply or divide both sides by a negative. Hint, you're going to be looking for a negative coefficient. And so let's talk about that a little bit and what that means. So if we look at this problem here, we have a multiplication problem, and how we solve multiplying is doing the inverse operation of dividing. And we would get for our answer x is greater than 2. So open circle and 2 and going to the right. And that means that all the numbers that are greater than 2 work. So if I plug in 3 for the x, I get 3 is greater than 2. That's true. When I plug in 4 right here, I get 4 is greater than 2. That's true. But the mess comes when I have a negative coefficient. Everything kind of goes crazy here. So I divide by -3 on both sides. Okay, and I get the x and the -2. And it seems like I should get this inequality. It should stay, but I'm going to put a question mark by it. Because when we look at -2, when we try the numbers that are to the right of it, that are greater than it, we'd get a number like -1 or 0. And when I try them, they don't work. -3 times -1, that says that 3 is greater than 6, which is false. 3 is not greater than 6. If I try it with a different number, say 0, okay, I get -3 times 0 is greater than 6. That gives me that 0. This is also not true. Okay. So it ends up being that none of the numbers to the right work. It's actually the numbers to the left that work. Because when I divide by the negative, I am reversing this inequality as I'm saying the opposite of this. And the opposite of a greater than is a less than. So when we go to the left and we try to plug them back in to see if it actually does work, I need to plug in a number that is to the left. And you'll see that now it actually does make a true statement. This says that 9 is greater than 6. That is true, and our equation should always be true, just like these over here were true. When I plugged the number in, it made something that truly worked out. Okay, so we are going to need to memorize this rule. Written in other words, okay, when do you reverse the inequality? When the coefficient, the number in front of the letter, is a negative. Okay, any point when you multiply or divide both sides by a negative. So we're going to be practicing that, just looking at it right now. This one you would leave, the coefficient's a positive. This one you would leave, the coefficient's a positive. This one you would leave, the alligator the same, coefficient's a positive. But all of these, we would have to flip the alligator around when we write our answer. This one has a negative coefficient, this one has a negative coefficient, and this one also has a negative coefficient. Okay, we're going to practice and look at it on some examples here. So don't overgeneralize the rule. The only time it gets confusing is when we have a negative coefficient. Okay, here's 2 examples already done for you, typed up, and then here's some that I'm going to do with you. This one here, we would divide by 8 on both sides. The coefficient's a positive, so we just leave it alone. It was a greater than, it's still a greater than. We'd use an open circle for whenever it doesn't have the line under it. And it's going to go to the right. Greater than numbers that are greater than 6 would be 7 is greater than 6. 8 is greater than 6. The numbers to the right are greater. Here's some examples of them. This one here is where we're going to need to flip. We are multiplying both sides by a negative. There is a negative coefficient right here. Okay? And when we do that, this symbol becomes the opposite of whatever it was. It's a less than, we make it a greater than. We do the problem exactly the same. I'm doing the inverse operation. This is division, the opposite is multiplying. So this is -11 times -2, which is +22. What was new is that alligator flipping. It stayed because it was a positive coefficient. It flipped because it was a negative coefficient. Closed circle because of the line under it going towards the right. When you plug in these numbers that are to the right, for example, 24, I'm going to add another one there. 24 divided by -2 is -12. -12 is less than -11. These are all numbers that when you plug it in should make a true statement. Okay, this is what I call a double flipper. We're going to need to reverse this inequality twice. I never like the variable on the right. So I need to rewrite an equivalent statement that has the variable on the left. This says that the C10 is greater than the 60. Pac-Man always eats the bigger one. The alligator mouth eats the bigger one. So when I rewrite this with the variable on the left, I need to switch it around. Okay. And then divide by 10, and I get C is greater than 6. Okay, no flipping again, just single time we need to reverse it. We reversed it here when we rewrote the equivalent problem with the variable on the left. We do not flip it again because it's a positive coefficient. So I'm looking down here for what numbers are greater than 6. So the numbers that are greater than 6 in here would be 8 and 50. Okay, show that 8 is part of the solution set. So show that 8 works for this problem. Okay, so I would plug in 8 for the C right here, and that says that 80 is the bigger one over 60, or 60 is less than 80. Here's a couple more examples if you need to look them over. This one is a flipper because I divided by a negative. This one stays because I'm dividing by a positive 1/4. This one flipped because of the fact that I divided by a negative. This one stays the same because I'm dividing by a positive 1/4.